Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part C, question number 28. The question is, in the AC Josephson effect, a supercurrent flows across two superconductors separated by a thin insulating layer and kept at an electric potential difference delta V. Now the angular frequency of the resultant supercurrent we need to find out the expression. So four options are given and we need to choose the correct option. So let's get started. So this question comes from the section solid state physics and the concept involved here is superconductivity. So superconductors are those class of materials which when cooled below a specific critical temperature showed a zero resistance. Now why zero resistance? Zero resistance is because two electrons are forming a bound state instead of repelling each other. Because when they repel each other, they create resistance. But since they are forming a bound state called Cooper pair, instead of resisting that, they create a zero resistance to the electric current, which is why the material, those class of material are known as the superconductor. Now, to understand the Josephson effect, first of all, you must understand the concept of quantum tunneling. Suppose there is a ball which is rolling on a surface and encounters a small hill. Now, if the kinetic energy of the ball is high and height of the hill is comparatively small, then the ball can easily roll over it and continue its path. But if consider a situation where the height of the hill is much higher, then the ball proceeds only to a part of the way up the hill and then returns back. It is not possible for the ball to pass over the hill in this scenario, and this is the classical situation. However, in quantum mechanics, if you replace the ball with electron and the hill with a potential barrier, because of the wave and particle nature, electron can tunnel through the barrier if the barrier is sufficiently thin, and that is the criteria where electron can penetrate through the potential barrier without sufficient energy and appear on the other side. And this is what happens in case of Josephson effect. So in Josephson effect, two superconductors are separated by a thin dielectric barrier. In this situation, now earlier we have discussed that in tunneling effect in quantum mechanics, electron penetrates through a thin potential barrier. But in case of Josephson effect, the Cooper pairs, because as we have discussed, superconductor have Cooper pair. So those Cooper pair can flow from one superconductor to other via a tunneling, and in this situation this pass through one part to other, considering the fact that when the concentration of the Cooper pair from higher side to the lower concentration, and in this scenario when they are connected by a wire, what happens is a DC current flows in the circuit, and this is called the DC Josephson effect, where the supercurrent is I is equal to IC sin phi, where phi is the phase difference between the Cooper pairs on either side of the superconductors. But suppose when the two superconducting materials are connected by a DC source, so in that scenario an AC current is produced. This is known as the AC Josephson effect. Why AC current? Because the supercurrent produced in this case will have an additional phase shift which depends on time, and the expression is given as I is equal to IC sin phi 2E delta V by H cross T. Delta V is the potential difference applied across the junction. Now, and why 2E? 2E because as I said they are Cooper pairs, so two pair of electrons are there, because that is why the 2 is eventually added here. Now since the current depends on time, and because of the time dependent phase shift term, this is an AC current. So in this question we need to find out the angular frequency. So if we compare this expression to the AC current sine wave equation, that is I is equal to IC sine omega t plus phi, and we need to find out the angular frequency, which is omega. So if we compare both the expression, we can see that omega, that is the angular frequency, is 2e delta v by h cross. Now let's check the option. Now if you can see the option, you can see that option given in the expression given in option A is matching our answer. So this is the correct answer.